The purpose of this video is to discuss how to predict products for chemical reactions. We're going to focus on three different types: single replacement, neutralization, and combustion reactions. Now, the single replacement reaction is composed of a compound plus an element that yields a new compound and a new element. Since Donald replaces Mickey, see, Donald and Mickey are similar, right? So they can replace each other. And this happens when metals replace metals or when halogens replace halogens. To be able to predict these accurately, you'll need the activity series on your formula chart. So if you look right here, this is what it looks like. That's your activity series. It's on the back of your periodic table. A more reactive metal replaces a less reactive metal. Potassium is higher on the chart than zinc, so guess what? Potassium replaces zinc. This reaction will occur. The other type is where a more reactive halogen replaces a less reactive halogen. Fluorine is higher than chlorine, so fluorine is more reactive, which means it will replace chlorine. So we look at our element, and I see, in this case, sodium is a metal, so we use the top part. Sodium is up here toward the top. It's going to replace another metal, which is copper. Copper's down here toward the bottom. So sodium plus copper. Since sodium is more reactive, that does happen. We write the formula Na2SO4 because we had to swap and drop to write the formula for an ionic compound. Copper was part of a compound. Now it's an element. It's all by itself. It's lonely like Mickey. Next, we have zinc plus sodium chloride. Zinc is right here, and then sodium is right there. Since sodium is higher than zinc, zinc cannot replace sodium. This reaction will not occur, so we write NR for no reaction. In the neutralization reaction, you have double replacement reactions. HBr plus NaOH, cation, anion, cation, anion, yield new products. NaBr plus HOH, or you could say H2O. Now all you do here is you take the anions and you swap them. That's all you have to do. If you swap Br for OH, you get NaBr and HOH. Then you have the combustion reaction, which is the same. It's always the same thing. The product will always be carbon dioxide and water. If you have a hydrocarbon plus oxygen, you will always get carbon dioxide and water. Well, what do you think the product of this combustion reaction is, right? We have a hydrocarbon, we have oxygen. What do you think the product will be? CO2 and H2O. Every time it's the same product. Now, sometimes synthesis reactions can also be combustion reactions. Not all synthesis reactions, though. All combustion reactions are synthesis, but not all synthesis are combustion. And it's strange, right? Because you go, how is this supposed to be a synthesis reaction? Well, you see the carbon and the oxygen here. You see the carbon and the oxygen there. Well, you get CO2. You see the hydrogen and the oxygen. Well, you have hydrogen and oxygen. So sometimes these reaction types aren't that simple, and sometimes a chemical reaction might be composed of several different reaction types.